So I have a question from a client, and the client asks, how can I determine if my strike, meaning electric strike, is AC or DC? And this video will solve and answer that question.
You want to figure out whether you've got AC or DC electric strike, okay?
Yeah. Well, the question I also have is, if I install the rectifier, I know I watched one of your other videos where, is there a chance of burning something or anything melting, or should it work properly?
The only time, you're not going to break anything per se, provided that you are using an AC power supply and a DC strike.
Okay. Well, I guess that's the question. What is it? Is it an AC strike? And I use a rectifier. What will happen?
Well, if you have an AC strike and you install the rectifier, it's probably not going to work like you want and will lead eventually to a product failure.
Okay. Now, would I be able to just replace the solenoid with like a DC solenoid?
Possibly. The electric strike, has solenoids available for it like that.
Yeah, because it seems like a very common design. It looks like the one you have on your website. So I was wondering if maybe I could just, if it doesn't work, maybe that'll be my next option, to just replace the solenoid to a DC solenoid.
Yeah, I mean, why not just solve this the proper way?
How's that?
Well, I mean, do you have incoming power to the strike?
Yes.
Okay, why don't you put your multimeter or your voltmeter on the power coming in?
Okay, and if it's 120, then it's AC?
Well, it's highly unlikely that it's 120. So right at the junction of where the strike is getting the power,
yes.
First of all, does it buzz when you use the strike? Okay.
That's the problem, yes.
That doesn't mean it's AC, but it most likely is AC, because with DC voltage, you could add an annunciator, which will give you a buzzing sound. But if it's buzzing, it's most likely AC voltage.
Okay. Yeah,
so
it's buzzing. And it's coming from the strike itself. There's no extra... Because I took it out, and it's buzzing from the solenoid. Yeah.
Okay, so then I would have to say that you absolutely have AC voltage.
Okay. Now, as far as the strike, how do I differentiate whether it's an AC strike or a DC strike? I guess as far as the solenoid.
Is the strike buzzing?
Yes.
Yeah. And you said it's coming from the solenoid. That means you've got AC voltage. You've got an AC strike.
Okay.
Well, let me back up. That doesn't mean you have an AC strike, but that for sure means you're supplying AC current to it.
Yes.
Yeah, that's. I don't know that you have, because I've connected DC strikes to an AC voltage and there's buzzing.
Okay. So I definitely need the rectifier, I guess, to first see if that works.
Maybe you might need the rectifier. Is the strike working or not working?
Yes, it works. It works fine. It's a brand new door. It's a brand new strike, and we're installing a new like a smart system with a key fob, and it's just the door's in a back alley, like a back entrance where it's very quiet, and the buzz is like it gets very loud. So I'd rather have just a click.
So what you should, and what do they want to do? Get rid of the buzzing sound?
Yeah. We just want a quiet, silent click.
Yeah, you're going to need a DC solenoid or a DC strike, and you're definitely going to need that rectifier that you bought.
Okay. Should I try, when I receive the rectifier, should I just try and install it first and see if it works? And if it doesn't work, then I guess try to identify the solenoid and order the solenoid, I guess? You
should, because if it stops buzzing, then and it works, you have a DC solenoid.
Solenoid. If it doesn't work, then I need one.
Yeah.
Okay. How do I identify the size and like would I take a picture of it and email it to you, or
email it. Disconnect it from power and don't cycle it, because we don't want to damage it prematurely. Yeah. And reply to that order confirmation you were sent, and I'll look at what you have.
Okay. All right, Howard. Well, thank you, and happy holidays. Stay safe.
You too. Merry Christmas. Thank you, sir.
Okay. Merry Christmas. Bye-bye. Thank you.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
So the client's question is, to interpret it literally, means, how do I tell the difference between an AC and a DC strike? Well, I've got two strikes here. I don't know which is AC and which is DC just by looking at it. You just simply don't know. You can't be sure. What you end up wanting to do is to inspect the hardware. Well, when I inspect this, ignoring the fact that this label is here, which does tell me what it is, and I know what it is, but I'm pretending I don't. These two black wires don't necessarily tell me what voltage this strike will run off of. I don't know. This strike here has a couple of wires, and they're white with orange stripes. That doesn't, you know, one's not black and white, and one's not red and black. Black and white, AC, commonly, right? Neutral and hot. DC, black and red. Negative and positive. These wires don't really tell me. So when we talk to the client asks, the easy way to most likely, in almost all instances, determine what voltage you have at the strike is, does the strike make a buzzing sound? If there's an audible sound that sounds like a buzz, it's going to, for sure, be an AC incoming voltage. The power coming in will be AC. That's really the only way that you'll hear a buzz, unless, of course, it's DC and you have an annunciator, meaning a buzzer has been added to the circuit. So as we can see, the buzzing doesn't necessarily tell us if it's AC or DC, because AC, the way that that wave is and how the electricity cycles back and forth 60 times a second is what gives the buzzing sound. You can take an AC transformer and wire it to a DC strike, and it will buzz. And it will possibly work, or maybe it won't work, but it will buzz. But that doesn't tell you if you've got an AC or a DC strike. You can take a DC power supply and you can connect it to an AC strike, and it may or may not work. I don't know, but we're going to figure it out. So the bottom line is, how do you know by looking at two strikes what's AC and what's DC? There is no foolproof way to determine that. The step to move forward is to visually inspect the equipment for clues. Is there a label on the strike that tells you what voltage it is? Or is there some code, as in the part number, that can be traced back to the manufacturer's catalog, like an indirect code, that will tell you what voltage it is? Like Adams Rite, for instance, has 3-digit codes that tells you the function and the voltage. Are there colors of wires that are a tip-off? And then finally, is there a buzzing sound? So that's how you would go about knowing, most likely, absolutely, what it is, except the only true way to know absolutely what you're starting with is by putting a multimeter on the incoming power. The power before the load, the strike, the electric strike is the load in this scenario. You want to get the volt or multimeter on the wires coming in from the load, and then energizing the circuit, running electricity through it, assuming that the circuit is open. That will tell you what power you are bringing to the strike, but that doesn't tell us if it's an AC or a DC strike, and it certainly doesn't tell us if you have the right strike to begin with. And that's where this client's question started. Hey, do I have the right strike to begin with? And the answer is, I don't know. What's the power coming in? Is it a transformer, which means AC, or is it a power supply, which means DC? The client doesn't know. Well, the only true way to know is to get the multimeter on those wires coming in, energize the circuit, and see what it is. You can test it right at the load, and then you'll know for sure. You'll test it before the load and between the power supply. Then you'll know what power there is, and then you can determine, does the operation work? If you have AC power coming in and the strike works and it buzzes, then you have an AC strike. If you have a DC strike and you power it with AC, does it work? The question is, I don't know. So the rest of this video is going to be taking I have a AC transformer, I have a DC power supply here somewhere, and then I know that I have an AC and a DC strike, and we're going to try it both ways to see what you could expect, because I don't know. I've powered DC strikes with AC voltage in the past. I know it'll buzz, but I don't recall if it'll work, and in fact, I don't think it does work correctly at all. So let's move on and let's experiment. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so what we're going to do is we're going to take this, what I know to be an AC transformer. 120 VAC input, 12 VAC output. Okay, 12 volt. So what I'm going to do is, I know that this strike will take 12 volts, and I know this strike will take 12 volts. They happen to be set up for 12 volts. If they were set up for some other voltage, I would need to either get a different strike or do something, or maybe change the voltage of the power supply. But the bottom line is, this is AC, and here's my DC power supply. The power supply can produce 12 volts. Okay, I'm going to get that set up. So first we're going to wire our 12 volt to each of these strikes, and we're just going to test the behavior is what we're going to do. And I have a whole mess of wire here, and I'm just going to pick a pair of wires and get that installed. You know, I'm going to use just black and white. Actually, I won't. I'll use green and red because I can differentiate those colors. It doesn't matter what I'm using, but I just need to make sure I'm using the right wire on the opposite side. Okay, so let's wire that. Okay, it's AC, so polarity doesn't matter. Which means you can put either wire on either terminal, is just what that means. That is not the case with DC voltage at all. Okay, so we've got our two wires wired. We're not going to plug it in just yet. And let's start with this unknown strike. I don't know what it is. We're pretending that I don't know what it is. Gonna need a couple of wire nuts, red and green wire stripper. Okay. We're just going to twist. It's AC, so don't really know what's going to happen. The power's coming in as AC. There's two wires here, and that's going to be normal, whether it be AC or DC, assuming that all you're doing is powering. So let me get a couple of wire nuts. We're going to cap these off, because if these wires were to short, it could do nothing and just short, and maybe a little bit of wire evaporates on us and goes away. It literally melts. Or it could just damage the circuit of the power that's coming in. We don't want to do that. It could obviously catch fire. It's electricity. Even though it's low voltage, it could certainly present the possibility of harm. So, okay. So this strike, I'm just going to set it up right there. It's locked. I'm going to work this transformer over to where I can plug it in about 3 feet away from me. So I don't know what will happen, so let's see. Okay, so we hear a buzzing sound. It's still locked, so it's a buzzing sound. And it doesn't work when it's buzzing. So it's buzzing, tips us off that it's probably AC voltage coming in, because the only other way you could get buzzing with a DC power supply is if you had an annunciator. It's a horn that's meant to give you a buzzing sound. In a DC circuit, some people want to hear the buzzing sound so that when they buzz someone in, that person being buzzed in can hear it, and then they know to pull the door or push the door. So you can have noise in a DC circuit. In an AC circuit, you're always going to have noise. In a DC circuit, you usually don't. You'll just hear a click. That's all you'll hear. So let's unplug that, because we are for sure not doing we are for sure not doing anything good to the strike while it's powered. So we know that this strike doesn't work. So let's try the other one. Okay, so we'll put that aside. Let's try this other strike. Well, I know one's AC and one's DC. This is locked. I'm always checking to see if the power is disconnected. Touching voltage is something that should never be done, certainly intentionally. I should say touching electricity. Voltage doesn't necessarily mean it's a dangerous circuit. Static electricity is voltage. Very dry environment. If you walk over a carpet with socks on, you'll touch a metal object and you'll get a little spark. Well, that can be a few thousand volts. But because the amperage is so small, there's really nothing dangerous about it other than the fact that you've got a little spark in your finger. But in our environment, we don't know what we're dealing with, so you always have to be quite careful of what you're doing. Well, we're going to plug this in. That's clearly buzzing. And it's unlocked. When I disconnect the power supply, that's locked. Here's what we know. We know it's AC coming in. We know the strike works correctly. It's locked when there's no power and there's buzzing, and it's unlocked when there is power or when the circuit is closed. So the true way to know what we're dealing with, and I'm going to disconnect this because I do have this disconnected. The true way to know what we're dealing with is to test the incoming voltage. So I'm going to put this strike aside. Now I'm going to plug in my transformer. I'm going to plug it in. My wires are not going to touch each other, so I'm not really concerned about that. So that transformer is plugged in. If you can, the way to be sure about this is you take your volt or multimeter, probably a multimeter, and you're going to set the multimeter, and don't touch it. There's power running to it. You're going to set your multimeter to AC voltage. That'll be here. You've got the V here, and you've got the V here. This has got a squiggly line next to it. That means AC. So you're going to set that dial to the higher value of what you think you're going to encounter. I know that that's a 12-volt transformer, so I'm going to set it to 20. The next highest number is what you'll set it to, never lower. So I've got it set to 20 because I don't expect to see more than 20 volts. So I've got it set to AC voltage, maximum 20. I turn it on, okay? And I'm going to basically touch my probes. Yeah, it's reading something there, isn't it? I'm going to put it down so I can see it. Yep, sure is. Giving me 14 volts. 14.77 volts. So that's what the transformer is putting out. Now, the question becomes is what if we set it to DC voltage? What would we get if I set it to 20 DC voltage? See that reading? On this model, you're not getting anything. So let's set it to 20 AC voltage. You're getting that reading. So that's a tip-off that you are good. I mean, that's not a tip-off. That tells you exactly what you're dealing with. I'm going to unplug that transformer now. Okay. So, we tried 2 strikes. One didn't work. One did work. We're going to strongly conclude that the one did work has to be the AC strike because we knew we were coming in with AC voltage. But the way that you would know is that you would put your multimeter on the power coming in, and then you would absolutely know. So the question becomes, could be for the client, I got a box of hardware delivered to the job site. How do I know if I have AC or DC voltage? I got to install it. Well, the question is, what's coming out of the wall? client doesn't know. Okay, so if you don't know what's coming in, and you really should, and you don't know what you have in your hand, and you really should, before you wire anything, we just took an AC transformer and connected it to a 12 volt DC and a 12 volt AC strike. One instance it didn't work, the other instance it did work. So I'm going to go with the instance that it did work, is that this strike has to be AC voltage. And I happen to know that this is a DC, a 12 volt DC. I know that it is. So what we'll do now is I'm going to plug in the DC power supply, and we're going to connect both of those same strikes, and we're going to then see what the strikes do, because I'm really not sure. What will an AC strike do with 12 volts DC? Let's find out. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's move on with our experiment. Now what we're going to be doing is connecting the power supply, the DC power supply, to both of these strikes. We'll find out what's happening. So let's disconnect the transformer. I think this is a 2 amp power supply. It's going to be able to produce 12 or 24 volts. I have this already wired so that I can just move quickly with it. Yeah, probably what I'll do is spin it around so I can wire it. And I know this Locknetics 510, that wire nut is on there. That's very important, actually, because I'm not grounding it, but if that were to come off and strike something, this is not electric tape, I'm just holding the wire nut on. If that were to strike something, it will short. So I know that this power supply has output power at terminals 5 and 10, so I'm simply going to connect my green and red wires at 5 and 10. 5 on the wiring diagram for the power supply indicates that that is the negative terminal, which would normally be the black wire. So the bottom line is, when we connect the green wire, we will be connecting it to what we understand to be a negative terminal. But since we don't technically know what these are, we will probably have to switch the wires to see what sort of behavior we get, because DC voltages, there's polarity with DC voltage. So I'm going to take this power supply, just move it aside for right now. It's not plugged in, but I do know that we've got it set to 12 volts, and this is set to 12 volts. There's a toggle switch for voltage. So let's stay in the same order that we were in. I don't know what this is, so let's just connect a couple of wires. And what we'll do with this example of DC voltage is we'll reverse the wires to see if we get any different behavior. So right now I've got green and black connected, just by chance. And by the way, I think I am a bit hesitant to just touching wires. As a 10-year-old child, I walked up to an electrified livestock fence, and I was not expecting that shock, and while it didn't cause me to do anything but jump in the air, it was not pleasant. So I'm going to power this. I'm going to power it, we're going to see what happens. Okay, that didn't sound right. That was a pop, is all I heard. A pop. Okay, that's unlocked. Okay, I pulled it because I didn't like the sound of that pop, and now it's relocked. So that tells me that it will work on that voltage. Now I'm going to reverse the wires just to see. We're just going to reverse these wires. This black wire will go to the red. Now reversing DC voltage is just going to make a motor run backwards or give you a negative value on a voltmeter or a multimeter when you're testing for voltage. Okay, so we have the wires reversed. I had to reconnect that. I'm going to plug it in and see what happens. Heard the same pop, and it's unlocked. So So it's getting voltage, and it's working. Unplug it. So reversing the wires didn't give us really much of a tip in terms of what would happen. So be mindful that that actually is a clue about what we're dealing with. It could be this worked with AC voltage. We know that. It worked and it buzzed really loud. That was the second time. And it also worked with DC voltage. Possibility that this strike will accept either. I mean, I think the old Star Trek saying is, you know, eliminate all possible causes, and what you're left with is the only reasonable explanation. And a reasonable explanation would be is that this can accept AC or DC voltage. That would suit the logic. So we're going to disconnect this strike, and now we're going to connect the other strike, and we're still pretending to not know what we have. So we know that this worked, and I'll tell you it's warm, and it was not plugged in very long. It's noticeably warm. That's also a tip-off. Strikes will get warm, but that couldn't have been powered for more than just a few seconds. So that's interesting. Very interesting. I don't know anything about this strike. We're going to connect it. Okay, we've got those wires connected. I'm going to power it. Okay, I heard a click. And it works. I heard a click and it works. Okay, great. Let's unplug it. And you may not have heard that, but within a second after I disconnected the power, I could hear the solenoid drop. Now all I'm going to do is reverse these wires, because emulating what you'll be going through, you wouldn't know what wires are what anyway. Meaning, you know, you're working without all the data. Okay, let's plug it back in. I heard the click. I think our wire came loose. Yeah, it did. I'll just hold that. And it's unlocked. So we know we're good. Okay, so that worked in both orientations. We're unplugged, I know that. So this strike worked with the voltage going in either direction. Now, let's talk about exactly what strikes these actually are so we can talk about the conclusions.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Now, for looking at the first strike, it's funny, it's still warm. So this worked on AC voltage, and it worked on DC voltage, and looking at the label tells us that this strike is 8 to 16 VAC and 4 to 6. So 8 to 16 volts VAC. We were supplying 12 volts VAC from our transformer. Output is 12 VAC. This will also work with 4 to 6 volts DC. So why is it warm? Because we were supplying at least double the amount of voltage that it is rated for. That would explain it. Now, will it work when you're sending far too much voltage? It will. It's just the electrical component is not. It's going to fail eventually, and it will probably fail as a result of the coils that make up, you know, the part of the unit that creates the electromagnetic field to pull a slider back or whatever, removing the blockage from the solenoid. Those will likely fuse together, and they'll create a short and it'll stop working. Is probably what would happen. So the fact that it's even still warm right now tells me that it's certainly going to be something that would be. Did tell me that it seemed like it was unnecessarily warm, and the point of that would be it would be something I would check immediately to make sure that we were not doing anything incorrect. Now, this second strike, I happen to know that it will run on either 12 or 24 volt DC, and I know that I have the 12 volt coil, so to speak, installed in here, the 12 volt coil assembly. But these coil assemblies will operate on either on AC or DC. I had the 12 volt. So you'll recall that in one instance it buzzed, and in the other instance it didn't buzz. So we knew, based on the fact that we were providing AC voltage, we would get a buzzing sound. And it's important to know what the amperage requirement would be for either instance to make sure that your power supply or transformer can meet that. So based on our experiment, it's hard to say what you have. And the only thing that you can use to help determine what you have without being able to look at a label and know what you have is to pick up on any clues that can lead you down a particular path. But the bottom line is, without this connected here before it gets to the load, there is guesswork involved. Multimeters like this are extremely inexpensive. I mean, they can also be expensive. I guess, you know, I have this one is extremely inexpensive. This might be something that's $30. It was a free tool through a class that I was in, and I have a more expensive unit as well. But at the end of the day, I'm just checking for voltage and resistance and continuity. You know, let me just tell you, I'm testing for voltage over here. I'm testing for continuity, and that's the little horn at the tip of my finger. And continuity is, I had a motor on my desk, and one of the wires was cut, literally separated. So I took the red of DC motor, I took the red and the black leads, I cut them both evenly, and then I repaired them. But I don't know if my repair worked, but the way I was able to absolutely know it worked is I tested for continuity through that. Or I could also test for resistance, which is the omega. That's ohms. Now, I don't know what the resistance value is of that motor, but I definitely received a resistance value coming through my multimeter. So I knew that the wire connections worked. I didn't know what every motor will have an inherent ohm value, or how many ohms. I didn't need to know what that was. The fact that I saw something that made sense to me in terms of what ohms would be for a small motor told me that my repair worked. So how do you know if you have an AC or a DC strike? You cannot know positively. You can wire and test, and you can run the risk of damaging material like your strike because you're applying too much voltage, right? Too little, it probably won't work. But that won't tell you absolutely. Analyzing what is occurring in front of you will likely tell you what it's not. Anything that's not perfect is probably what it's not. And when you have an instance where it works perfectly, that's probably what it is. So invest in a multimeter, test at the load. You have to actually close the switch, let's say, and get power to the load to be able to test your voltage. Or you'll test voltage right inside of the power supply or at the transformer. If I plug this in and put my probes on here, this will read plus or minus 12 volts typically. If you have any questions on how to figure out what voltage you have in terms of hardware in front of you, please feel free to reach out to us. And thank you.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
May I ask you a general technical support question?
Sure.
If I have two strikes on my desk and I'm told one is AC and the other is DC, is there anything I can do with my multimeter to determine which is the AC and which is the DC?
No. Not that I would ever, no, not that I'm aware of. There are SDC strikes? Security door control strikes?
The one that's here that's DC is an SDC strike.
Okay, I was going to say, my strikes all say right on the solenoid, it'd be stamped AC or DC.
Yeah.
So if you're looking at a different manufacturer's strike, it might be worth, I don't know if you can open it up and actually physically see the solenoid, but it might be stamped AC right on it.
Yeah, because I know I can power a DC strike with an AC transformer, and I'll hear it buzz. So it really boils down to you've got to check the power source to
Correct.
know what you're dealing with. Yeah, okay. Kelly, thanks
Right.
as always. Have a good one.
Yep, you too. Thank you.
Bye.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.